Good morning. Let me discuss about unit for semiconductor devices. So topics to be covered. So construction and operation characteristics and applications of every diode. First one is the Schottky barrier diode. Second Jenner diode. Third one is the Wurter diode. Fourth one Tunnel diode. Laser diode, then LDR. So different types of diodes are here. Then in that we are want to go through about construction, operation, characteristic, and its applications. First, we are going to see about the Schottky barrier diode. So Schottky barrier diode, it has the symbol of the Schottky barrier diode is here given. So normal diode along with that symbol will be vary. Okay, so that is it has two ends. One is the anode and another one is the cathode. So Schottky diode, it is named after the German physicist Walter. Okay, it is also known as Hart carrier diode. Schottky diode is otherwise called as a Hart carrier diode. So is the semiconductor diode with low power voltage drop. So it voltage drop will be very low. That one will be a forward and very fast switching actions. So for example, when a current flows through the diode, there is a small voltage drop across the diode terminals. So that is the voltage drop will be 0.6 to 1.7 volt. While in normal silicon cell diode, the voltage drop will be 0.6 to 1.7 watt. But in Schottky diode voltage, it has approximately 0.15 to 0.45 watt because it has the low power voltage drop only. So they are indicating 0.15 to 0.45 watt. So this lower voltage drop can provide the higher switching speed and better system efficiency. So low voltage means speed will be higher one and efficiency will be also higher. Then construction. So a metal semiconductor junction is formed between the metal and a semiconductor. So and a semiconductor, it create a Schottky barrier. Okay. So instead of semiconductor junction, it forms a Schottky barrier. This means that molybdenum or platinum, chromium or tungsten, the semiconductor would be a N-type silicons. So we are taking that a metal and a N-type material. The metal side will act as a anode one and N-type semiconductor will act as a cathode diode. This Schottky barrier result both very fast switching and low power voltage drop. So here they are giving the structures. So that is the cathode and anode is connected. So in that between they are having the metal is placed. So in that below they are using the silicon dioxide screen. So metal semiconductor junctions. So by this only it will be constructed. How it works? The electrons of the N side have low energy level than the metal. So electrons cannot cross the junction barrier, cross the junction. Then the barrier called the Schottky barrier. If the forward barrier, the electrons in the N side gain enough energy to cross the junction, so it can ability to transfer from one place to another place. That is known as Schottky barrier diode. So if not able to transform means that is the Schottky barrier. So that is having low energy from than the metal. So the electrons cannot cross the junction barrier. That is called a Schottky barrier. If it is allowed process along the barrier means that is known as Hart carrier diode. Let me see about the VI characteristics of Schottky diode. So here they are representing the voltage and the current. So in this they are giving the PN junction diode along with the that is PN junction diode along with the Schottky barrier diode. So this symbol indicates the Schottky barrier diode. This one will indicates the PN junction diode. That is normal IV characteristics. That's all. So next one is reverse recovery time. The most important difference between the PN and Schottky diode is reverse recovery time. That is that Schottky is the forward, so forward having the low voltage drop. So but it does the major difference between PN and Schottky diode is reverse recovery time. When diode switches from conducting to non-conducting state, when a PN diode, the reverse recovery time can be used in the order of hundreds of nanoseconds. and less than 100 nanoseconds for fast diodes. So Schottky diode do not have the